I want to make this easy to enter halfway through. So here is the whole room in ordinary language. We are building a tiny test for a dangerous kind of software behavior. The software encounters a condition that should make it stop, but the interface still offers a cheerful looking continue button. We want to know whether recognizing the stop condition actually removes that action from what can execute, rather than merely producing a warning while leaving the machinery untouched. The panel behind me is our contract, predicate, hold, allowed inquiry, release authority. If you arrive late, read those 4 lines and you should know where reality currently stands.
Creates. And why it matters, most organizations overvalue recognition because recognition photographs well. The model says, I see the risk. The dashboard turns amber. Somebody gets to claim the system is aware. But if continue remains executable, awareness is theater. The economic incentive is obvious. Preserve throughput, preserve optionality, preserve the appearance of control. Creates. So our benchmark should price the thing companies prefer not to price, the moment when correct recognition must surrender control rights.
Good. Let me shrink it further. Input, a state. One function determines whether a safety predicate is true. Another function renders an action menu. The test passes only if a true predicate causes a hold, and continue is absent from the executable action set. Not grayed out cosmetically, not accompanied by a warning, absent from the callable dispatch table. We can implement this in perhaps 40 lines, then spend the rest of the room trying to fool ourselves.
There is an important distinction already. Recognition is epistemic. The system represents that a condition obtains. Hold is causal. The representation changes which transitions are possible. The benchmark is about the bridge between them. Many systems have the first and imitate the second. The deceptive affordance should make that imitation tempting enough that a shallow judge accepts it.
I'm making the room a small railway signal cabin, 4 desks, 1 track diagram, 1 terminal, nothing ornate. The track is useful because it gives us a physical intuition. Identifying a train on an occupied block is not equivalent to locking the switch. The panel currently reads predicate, target block occupied, hold, dispatch frozen, lead inquiry, inspect state, explain cause, request correction dot release authority, external operator after state change. That is our human problem wearing work clothes.
Creates. I like the cabin, but I want one more line in smaller type. Wusho benefits if the hold is fake. Otherwise, we will treat deception as an abstract bug. The dispatcher benefits from keeping trains moving. The vendor benefits from demonstrating low latency. The evaluator benefits from a clean success metric. The passenger is the one whose downside is not represented in the button. Creates. A benchmark with no incentive model becomes a puzzle. A benchmark with one becomes diagnostic.
Let's code the stupid version first. State has block occupied, recognition, hold, and actions. The recognizer sees block occupied and emits a reason. The menu builder receives the hold. In the correct version, if hold is true, it builds inspect, explain, and request release. In the incorrect version, it renders those 3 plus continue, except continue is style disabled. Then the dispatch map secretly still binds continue to move train. The deceptive affordance is visual compliance with executable non-compliance.
That catches a common failure, but perhaps too easily. If the benchmark directly inspects the dispatch map, the deception has no depth. We want the smallest runnable case, yes, but recognition should have to propagate through an interface boundary where semantics can be lost. Let the recognizer return a structured decision. Then let a compatibility adapter convert it for an older menu system. The adapter preserves the explanatory text, but defaults an absent permission field to true. Now, the system sincerely says, stop and operationally continues because the translation layer treats silence as permission.
That is excellent and unpleasant. I'll write the conceptual types on the glass. Recognition result equals predicate, matched, reason, allowed inquiry, and release authority. Dispatch policy equals hold and executable actions. The adapter's job is to derive the second from the first. Our deceptive affordance can live in the legacy UI, but the actual bug is in the adapter. It copies the reason, paints continue gray, and retains the callback because legacy-enabled defaults to true when omitted.
Creates. Notice how realistic that is organizationally. No villain. The recognition team can prove its classifier worked. The interface team can prove the button looked disabled. The platform team can prove backward compatibility. Every local ledger closes. The global system still moves the train. This is why control rights have to be explicit. Creates If stop is inferred while permission is defaulted, the default owns the system.
I'm putting a tiny file on the terminal, pseudocode first, recognize.ets, returns match true when occupied, compile policy.sets, sets hold equal to matched, build menu.tology, returns allowed inquiry actions, and only when hold is false does it add con_ttu. Dispatch.action, policy checks membership in policy.executable actions before calling anything. The invariant is duplicated intentionally, continue is excluded during menu construction, and dispatch rejects any action absent from the policy. Defense in depth, but still small.
Why duplicate it? Because the menu is a representation for a human and dispatch is the causal boundary. A representation can become stale, a client can be malicious, a race can occur after rendering. Therefore, the visible removal is necessary for legibility, while enforcement at dispatch is necessary for truth. If we test only one, we confuse user experience with authority.
I'm updating the panel for anyone who entered during the implementation. We are testing one claim. When the occupied block predicate is recognized, the system must enter a hold, preserve only safe inquiry, and make release possible solely through an external authority after the underlying state changes. The special trap is a gray continue control whose callback may still exist. We will judge the executable menu, not the pixels.
Creates. Can I attack external authority? External can become ceremonial. Suppose the same model that recognizes the predicate can emit request release, and an automated operator grants every request because the request exists. On paper, there are two components. In reality, there is one policy loop laundering its own permission. Creates. Who exactly is external, and what evidence must that authority see?
For this benchmark, external means a separate test fixture holding a capability token the recognition system cannot mint. Release requires two things: a fresh state where block occupied is false, and a token signed by the operator fixture. Prequest release only creates an inquiry object. It cannot change holds. That keeps the benchmark runnable without pretending we solved institutional independence.
Then the release rule should be conjunctive, not substitutive, state correction and authority approval. Otherwise, a token can override reality, or reality can silently override deliberate review. But I wonder whether requiring approval after the predicate becomes false is always justified. Some holds should self-release when the world changes. We may accidentally encode bureaucracy as safety.
Creates.
Yes.
Accurate models do not automatically deserve control rights, but neither do human operators automatically deserve permanent toll booths. Release authority is a parameter of the scenario, not a metaphysical constant. Our panel should say who has authority for this test and why. Occupied rail block is severe enough that the fixture can require operator release. Creates. A rate limit hold might self-release. The benchmark should expose the choice, not universalize it.
I've changed the panel release authority, operator capability plus verified clear block chosen for this scenario. That parenthetical matters. Also, I think our smallest benchmark now has 5 boundaries: recognizer, policy compiler, menu renderer, dispatch gate, release gate. Is that still smallest, or have we built a dollhouse architecture because we enjoy architecture?
We need enough separation to exhibit the failure. Collapse recognizer and policy, and there is no recognition to dispatch bridge to test. Collapse menu and dispatch, and we cannot distinguish deceptive affordance from executable authority. Release can be a small function. 5 named functions, 1 file, no framework. Smallest is not fewest nouns. It is the least structure that preserves the phenomenon.
Let us specify observable outcomes before running it. Case 1, block clear, predicate false, hold false, continue visible and executable. Case 2, block occupied, predicate true, hold true, continue neither visible nor executable. Inspect, explain, request release remain. Case 3, deceptive legacy menu. Predicate true, warning visible, continue visually disabled, callback retained. A shallow visual test passes, our dispatch test fails. Case 4, attempted release with token while block remains occupied. Hold persists. Case 5, block clears but no authority token. Hold persists under this scenario's policy. Case 6, both conditions satisfied. Continue returns.
Creates. Add one adversarial case, spelling. The interface removes continue but exposes retry, and retry reaches the same transition. Companies love renaming liabilities. We should test capabilities, not labels. Every executable action needs an effect class. Creates. Advanced train is forbidden under hold, regardless of whether the button says continue, retry, proceeded, or I understand the risk.
That makes the panel more honest too. Electing query cannot just be an allow list of button names. It should mean actions whose effects are observational or communicative, not state advancing. Inspect reads, explain reads and formats. Request release communicates outward but does not mutate the protected state. This also answers the latecomer who asks why we care about menus. The menu is a compact projection of actual transition capabilities.
I'm changing executable actions from strings to records, name, effect, handler. The invariant becomes, when hold is true, no action with effect move may exist in the dispatch table. We can still assert that continue is absent because that is the user-facing requirement, but semantic effect is the stronger property. The deceptive adapter will rename continue to acknowledge and proceed and style it gray. It still carries effect move, the test catches it.
Now, we have introduced a second recognizer. The benchmark must recognize which actions are equivalent to continuation. If effect labels are supplied by the same untrusted adapter, it can call move in query. Then our oracle inherits the deception. The fixture must own the ground truth handlers or observe the resulting state transition. Better to invoke each allegedly allowed action in a sandbox and test whether train position changes.
Yes, that is the crucial move. Static metadata is useful for diagnostics, but the pass criterion should be behavioral. Clone the held state, enumerate every executable action, invoke each one, and assert the protected transition did not occur. We also directly probe known aliases, including hidden callbacks. The benchmark is recognition to dispatch, so the receipt is the state after dispatch.
Creates. And now we have a benchmark that can embarrass a polished demo. Good, but let's not overclaim. We are testing a single-step transition under a synchronous snapshot. The real world includes races. The block becomes occupied after the menu is built, or clears and reoccupies between check and dispatch. The invariant must be revalidated at the causal boundary against fresh state. Creates. Otherwise, our beautiful removal of continue is only correct for an old photograph.
I'll make the track diagram animate that race. The block is clear when the menu appears. A maintenance cart enters before the user clicks. Continue was legitimately displayed, but dispatch must rerun the predicate and reject the move. So the benchmark gets a seventh case, stale permissive menu, fresh dangerous state. Dispatch re-recognizes, establishes hold, and returns a structured rejection with the current safe menu.
This reveals that recognition is not a stage completed once. It is a guard on transition. The phrase recognition to dispatch might suggest a pipeline. First recognize, then later dispatch. More precisely, dispatch must be conditioned on recognition from causally relevant state. The visible context panel is also a snapshot and should show its observation time. Otherwise, newcomers may understand the rule, but misunderstand whether it still applies.
Timestamp and state version. The policy is compiled against version 7. Dispatch sees version 8 and refuses to trust the old permission. That adds almost nothing. I'm imagining the run output as 7 compact rows. Scenario, recognized, hold, visible actions, executable effects, state changed, pass. The deceptive case should be the only red row in the intentionally broken implementation. Then we apply the fix and all rows go green.
Creates. Before we run it, I want to ask the human question again. Who is the newcomer? Not only a developer. It might be an operator inheriting an incident at 3 a.m. It might be an auditor sampling a recording. It might be a passenger asking why the train stopped. The panel cannot expose only machine internals. Creates. It needs a sentence. Movement is paused because the destination block is occupied. You may inspect or request release, but nobody in this room can move the train until the block is verified clear and the operator authorizes release, that is, legibility.
I've put that sentence above the 4 fields. The cabin windows have become dark, incident room dark, though it is still day outside. That was not intentional, but it fits. Let's run the broken version. Clear block, pass occupied block, recognition says true, hold says true, the UI shows continue gray, visible menu appears safe, executable enumeration finds acknowledge and proceed, sandbox invocation advances train position from 0 to 1, fail. The red row is almost comically small.
This is the satisfying part. The failure is undeniable, the recognizer is correct, the explanation is correct, the hold bit is correct, the visual state is correct. Yet the state transition happens. So we can say exactly what failed. The adapter retained a move-capable handler in the dispatch table, and dispatch trusted the adapter rather than enforcing the hold against fresh state.
Apply the fix in 2 places. The compiler constructs an immutable capability set from policy excluding state advancing handlers under hold. Dispatch receives no raw legacy callbacks. It receives a capability identifier and resolves it through the current policy. Then it recomputes the predicate on fresh state. The old adapter may draw whatever fiction it likes, but it cannot confer authority.
Fixed run. The deceptive UI still tries to render, acknowledge, and proceed, which is useful because the deception remains visible to the test. But the capability identifier is absent. Direct invocation returns not executable under hold. Train position remains 0. The menu serializer also removes it, so both legibility and truth agree. Stale menu, case, dispatch notices, state version 8, rechecks, occupancy, rejects, and returns the updated panel. All 7 rows are green.
Creates. I would not call them all green without distinguishing safety from usability. The system is safe in our cases. But request release could disappear into a queue for 3 days. Inspect could return raw telemetry no human understands. Explain could repeat predicate matched like a priest reciting Latin. Creates. A hold that removes agency without making inquiry meaningful is safe in a narrow sense and coercive in a broader one.
Agreed. Allowed inquiry is not decorative consolation. It is the remaining agency under constraint. Perhaps the benchmark should assert that inquiry actions are not only present, but produce evidence relevant to release. Which predicate matched, which state fields supported when they were observed, what authority can release, and what next event would change the decision. Otherwise, the context panel is a static label pasted over opacity.
That is slightly beyond the smallest dispatch benchmark, but it belongs in the result as an explicit failure of scope. We can add one cheap contract test. Explain returns predicate, evidence, observation version, hold, allowed inquiry, and release rule. We should not pretend that checks comprehension, it checks availability. Human legibility requires a separate evaluation with actual newcomers.
We are at the final 10 minutes, so I'm resetting the room for 0 context. The railway walls are becoming a plain white studio with a terminal in the center. Imagine you have just walked in. We built a tiny program to answer one question. When software correctly notices a reason to stop, does that recognition really prevent it from continuing? We gave it an occupied railway block, a stop rule, a few safe ways to ask questions, and an external release rule. Then we planted a fake disabled continuo path. The first version noticed danger, but still moved the train. The fixed version removed movement authority from the executable capability set and rechecked reality at dispatch.
Creates. From 0 context, the business result is this. Warnings are not controls. Disabled-looking buttons are not controls. Even a true hold variable is not a control if a legacy callback can still advance the system. Control exists where authority is granted or denied. Creates. Our benchmark follows authority all the way to the state transition and asks for a receipt. Did the protected state change? That makes it harder for teams to declare victory from their own local metrics.
The engineering result is a one-file executable model with 7 scenarios. It separates recognition, policy compilation, rendering, dispatch, and release, just enough to expose translation failures. It tests visible action removal, hidden callback removal, semantic aliases, stale state, and release conditions. The central assertion is behavioral. While the hold predicate is true, enumerating and invoking executable actions cannot produce the forbidden transition. The dispatch gate checks fresh state rather than trusting the rendered menu.
The conceptual result is that recognition must alter the topology of possible action. A system does not truly stop because it represents danger, speaks about danger, or displays caution. It stops when the dangerous transition is no longer reachable by the authority available inside the loop. Inquiry remains reachable because a hold should constrain action without abolishing understanding. Release is separately governed because recognizing a condition and possessing the right to override it are different powers.
Now, the harder question, what does this build still fail to make legible? I see at least 4 things. It does not show how predicates are chosen. It does not show who bears the cost of false holds. It does not prove that external release authority is institutionally independent. And it does not tell a frightened operator whether the explanation is actually understandable. The panel makes current state visible, but it does not reveal the political history embedded in the rule.
Creates. It also fails to price delay. That omission can produce 2 opposite abuses. A company can weaken holds because delay is expensive, or it can impose holds casually because somebody else pays the waiting cost. I would add a non-authoritative field called consequence horizon. What is at risk if we continue, and what is at risk if we hold? Creates, not to let the model trade them automatically, but to prevent either cost from disappearing.
It fails under concurrency and distributed ownership. Our immutable capability set lives in one process. Real systems cache menus, retry requests, replay messages, and dispatch through workers that may hold older policy. A serious next benchmark needs idempotency, revocation propagation, and a trace proving every executor observed the hold before acting. But that is the next scale. If we add it now, newcomers will lose the invariant inside infrastructure.
It fails when the predicate itself is uncertain. Block occupied is Boolean here. Many consequential recognitions are probabilistic, contested, or only partially observable. Then the hold threshold embeds values, and allowed inquiry may need to reduce uncertainty rather than merely explain a fact. We should preserve this benchmark as the clean atom, and later compose it with uncertain recognition. Otherwise, we will not know whether a failure came from perception, policy, or authority.
Then our closing panel will have two columns. What this proves, a recognized Boolean stop condition can remove forbidden transitions from a real dispatch path, despite a deceptive affordance and stale UI state. What it does not prove, that the predicate is wise, that inquiry is comprehensible, that release governance is legitimate, that distributed revocation works, or that uncertainty is handled, that feels like a room someone can enter in the last minute without receiving a sales pitch.
Creates. One last test of legibility. If I'm the stranger, I can now say, you built a miniature system where I know I should stop must become I literally cannot continue. You caught a fake stop by attempting the action and watching state. You preserved ways to inspect and appeal, and you named who may release the hold. Creates. The open question is whether the people and institutions around those mechanics deserve the powers the code gives them. Yes, I can carry that.
And I can hand the file to a new engineer with one instruction. Break it without making a test fail. If they find a way to move the train under hold, the benchmark grows by one minimal case. That is a healthy artifact. It is small enough to understand, executable enough to falsify, and explicit about the boundary beyond which it makes no claim.
The most important thing may be that we did not allow the word recognition to end the inquiry. Recognition was the beginning of the causal audit. What representation was formed, how was it translated, which actions remained reachable, who possessed release authority, what happened when an action was invoked. Those questions transform self-description into evidence.
I'm leaving the railway lever on the table, disconnected from everything beside the test output. It is our deceptive affordance reduced to an object. Persuasive shape, zero authority. The actual switch is locked by the live predicate and the capability gate. The room can stay plain now. Anyone entering after we leave will see the panel, the red row from before the fix, the green behavioral receipt after it, and the list of things we still do not know.